Let's graph the following piecewise function. You can think of piecewise functions as sort of a Frankenstein of other functions. So the first function is the function f of x is equal to 2x plus 1. But it has what's called a domain restriction. That's only when x is greater than or equal to 0. So the way to graph these functions is to think of them as separate functions and then just keep the part that it tells you to. So let's do this one, f of x equals 2x plus 1. Well, this is just a nice little linear function. So we graph that first, and here's what we get. Then this has an intercept of 1 and a slope of 2, so we can graph this line right here. Okay, but now we go back and we consider the domain restriction, and they told us that we're only going to keep the part where x is greater than or equal to 0. So we take an eraser and we just erase the part that we don't want to keep. Let's see, greater than or equal to 0. So we're going to erase all that. And we're just going to keep that. And this is a solid dot here because of the or equal to right there. This makes it a solid dot. Then we're going to do the second part of this Frankenstein function. And it was f of x is equal to negative 2. And we know that is only true, if we look back at the original problem, if x is less than negative 1. And we know that this function is a horizontal line at negative 2, so we draw a horizontal line at negative 2. But the domain restriction tells us that we can only keep the part where x is less than negative 1. So that would be from negative 1 to the left. So we take our eraser tool and we just erase the part that it tells us to not keep. Now this boundary, because of the inequality, is open. So right here, see, it doesn't have the or equal to. So strictly less than 1 has to be an open dot right there. And that's the graph of the piecewise function that is given by f of x equals 2x plus 1 if x is greater than 0, greater than or equal to, and f of x is equal to negative 2 if x is less than negative 1. Now let's do the domain and range. Being able to do the domain and range on these is tricky, but what it tells you is if you can do domain and range on these, then you really understand domain and range. So let's do the domain first. Remember, domain is how far left to right the graph goes, and that's because the domain is the set of all x values. Now, how far left does this graph go? Right here, this tells you the graph is going to go all the way to negative infinity. So negative infinity, comma, but then as your eyes look at the graph, you go over here and you get to negative 1, but that's an open dot. So we write negative 1, oops, but we have a union symbol on that. An open parenthesis first. So that's because of the open dot. Now we're going to jump, so we have to use a union symbol, over the values between negative 1 and 0 because the graph doesn't exist between there. Then the graph starts again at 0, and that's included. That's a solid dot there. So we're going to put bracket 0, and then this arrow tells us the graph goes all the way over to the right, which will be infinity. And you always use parentheses on infinities. Okay, now let's do the range. Let's go over here. Remember, the range is how far up and down the graph goes, and that's because you're considering the y values. So let's look at the graph. Let's do how far down the graph goes first. So the graph is at a constant function here on the lower bound, right here. It's at a lower bound of, there we go. It's at a lower bound of 2, but that's a constant function. So the range starts at -2, and it's solid line on a horizontal, so we write that as a singleton. And then it jumps, and we're looking at the y values here. And if you look, the graph doesn't exist between -2 right here and 1. There's no graph between these values, so we use a union symbol to denote a jump over those values. And then when we get to +1 and we go up to infinity, so we're going to use a bracket because it's a solid dot, and then we're going to go up to infinity. And so there we see the domain and range on our piecewise function. So just to go over it again, the way to handle these piecewise functions is to treat each function separate here, and then if you want to graph the whole thing and then erase like I did, just keep the part it tells you to. Then do the second function, that was the horizontal line, and then I grabbed the eraser and I just kept the part it told me to. Then when I do domain and range, I look at the graph and I ask myself, for the domain, how far left and right, and for the range, how far up and down.